All right, everybody, we're going to be working on Module 2 lab here for the remaining portion of the class, or most of the remaining portion of the class. And let's read through what our goal is here. And it says you've been asked to create a program that converts units of volume in the kitchen. Ask the user to enter an amount in milliliters and then select the units they want to convert to: teaspoons, tablespoons, cups, and quarts. All right. Output the converted amount of the new unit of measure, round the amount to one decimal place. All right. And then there's like a sample program run down here. So, for example, you might enter an amount in milliliters, for example, 75. And then we're going to put a little menu on the screen. So, this is kind of interesting. So, we're going to prompt the user to make a choice. Now think about how this is going to work. So they're going to type in 75 milliliters and they want to convert that to, I don't know, cups, right? So they're going to type the number 3. They're going to choose from our menu. And then depending on that menu choice, we'll run an if statement in the background that responds to that menu choice and then writes or runs the correct code to do the conversion to whatever thing they want to do. So we're really kind of ramping up our program design here. And this is our first program where we're putting in a menu and giving the user a choice on what they're going to do in the program. Right. Now, because we're going to have 4 different choices that they can select from, we do have to test all 4 scenarios. All right. I can't help but notice, though, as I run this lab, I'm like, all right, they tell us to do these conversions, but they don't tell us what the conversion values are. Like when we had the Monster Energy drink, it was like, okay, well, it's got this many calories, this much sugar, whatever. It was given to us. Uh-oh, we don't have that here. Yeah, not time to panic though, because we can look this stuff up, right? And so this is kind of interesting because Google does this natively, by the way. Convert milliliters to what was one of the scenarios? How about teaspoons? And you know what? Google's got it all out there, folks. And what I think is kind of fun about this is we got to figure out what numbers we're going to use to do these conversions. And I think this is definitely pretty interesting because depending on how your brain thinks, you might latch onto this right away and you may not. Okay. And I think this is pretty interesting because when I think of a conversion like this, we're going to convert milliliters to teaspoons. I don't know if I want to be multiplying with this number here, I guess, but what choice do I have? If I'm, and so let's like talk this through. And then let's look at the example here, because if somebody types 75, it needs to convert it to teaspoons. So I could kind of do that here. I mean, I can just type in 75. They have a tool and it tells me what the answer is. Okay, so how did that work? I had a 1 here before. So what's the conversion amount? Hmm. These are really interesting questions. So what's the actual, okay, it says formula, divide the volume value by 4.929. They're telling us right here what the formula is, kind of in a simple way, assuming that we're talking about volume, right? So that's the conversion amount for a teaspoon. So what I could do, and this is what I'm going to do in my code. All right, so let's go back to Visual Studio here for a sec, and let's I guess start a new project, right? Let's start to get to the point where we can code this, because what I'm going to do is I'm going to gather my thoughts and my data, and then I'm going to put it into my program as comments. So I have all the conversion amounts and formulas just kind of typed in as comments, and then I can start moving it to code. So this is how my brain thinks. For you, it might be pencil and paper, right? I'm not sure, how does your brain work on this stuff? Let's label this as what it is. This is the module 2 lab. No top level statements on this one. And then we'll get rid of this stuff right here. I am going to put in comments here. So for example, if I'm converting to teaspoons, what did it say it was? 4.929. So 4.929 milliliters equals 1 teaspoon. Is that correct? Okay, here's how we can test it, by the way. I can type in 4.929, and yeah, that's really close to a teaspoon. Apparently, there's more digits there, but this is such a minuscule amount, or we'll call that a teaspoon. And we know, I mean, they're telling us, right? Divide the volume value by 4.929. And this is really kind of an interesting little equation because some of us would look at this, right, and look at this number. Could I use this number in the calculation? This is my question for you. Your brain should say yes, right? Like, and I get a lot of you are not mathletes or anything like that, but if I divide the volume by 4.929, could I also multiply by 0.202 or whatever and get the right value too? Okay. And this is how your brain should start to think. It's like, well, I don't know. Can I try it? You know? Yeah, so that's kind of like where your mind goes. Now, of course, we can convert from milliliters to teaspoons. We're also asked to convert to tablespoon. And I think this is kind of fascinating. You notice how there's a US tablespoon and there's an imperial tablespoon. So they have different ones in England than we have here. Yeah. Thanks. Non-metric system, for complicating things so much. But yeah, in the US, we have different measures. So here it says for an approximate result, divide the volume value by 14.787. And so, in other words, here's what I'm coming up with. And I'm just going to paste this into Visual Studio. I got that one, but I also have the tablespoon, right? And then, of course, we'll have the cup and we'll have a quart and whatever. It doesn't matter what order I put them in, but you can go through this little chart here and pick up a cup. And that's multiplied by, oh, that's really interesting. Divide the volume by 240. That's not what I had here in my code before. But hey, do they have a different cup? It's the Imperial cup. Interesting. That's very interesting indeed. All right. So I'm just going to go with the number that they have here. If you guys are curious, what I have in my old code for some reason is this value for a cup. But they said 240, right? So I'm just going to go with 240. And then, of course, for a quart, let's type that one in here too. Uh, 946.4, which is roughly what I have. So I'll copy that value. And I guess last time I must have done this, they must have had more precision on this or something in the formula on Google than they do now, because I am seeing different values. So, all right, let's just come over here and say that number of milliliters equals 1 quart. But the whole point is, like, we don't have this information, but it's not like we're completely helpless. We do have the internet at our fingertips and we can look this stuff up. And it is kind of one of those pressing concerns of programmers is like, hey, how do you remember all these formulas and stuff? You don't, you just Google them, or you have, a mathematician that feeds them to you. All right. So another thing that we're going to do, it's kind of funny here, is we're going to ask people to make a selection from a menu. We're going to have to build that menu. But first, if I remember from the sample, I'm trying to find my thing here. First, we're asking them to enter an amount in milliliters, right? So that's actually the first question. So here's what I'm going to do. I'm going to prompt them for that. So I'm going to run um, a prompt, and I'm going to move it down here, right? So we're going to label this as input. And then I'm going to throw a statement up on the screen. And I know you guys are scrambling to catch up with what I'm writing here because I'm copy pasting. So I'm asking them to enter an amount in milliliters, just the same way it was written in the example. We're going to capture that, of course. Should that be an integer? Should it be a double? What should it be? All right. Well, you can argue all you want. I think, from thinking about it and discussing it with prior groups of students, I think we kind of resolved that a double is maybe a good idea because they might enter a whole number, but if we're doing conversions and divisions, right? Like we already learned this lesson, if we want more precision, we should probably use double. It's more precise, especially for multiplying and dividing. All right, so there's our capture of the input. All right, so once they've done that, we want to put a menu up on the screen because we've captured those milliliters and we want them to then make a selection from the menu. But here's kind of like my thinking. I could do this, right? And I'm just going to throw this code up on the screen. So don't panic and try to type it all in at once. All right. I'm you can type it in slowly, right? My thinking is, okay, that's pretty easy. I can put a menu on the screen by just typing this stuff, right? And then I can ask them via a prompt which one of the things is a choice. But how about this weird scenario? What if like the first thing they type, enter the amount in milliliters? Okay, what if they enter 0? And my thought is they don't want to convert anything. So why should I put a menu up on the screen? So follow my logic here on this. I might ask them first, if the milliliters is greater than 0, then I should put the menu on the screen. You see my thinking? If it's not, then why bother? They're obviously not taking it very seriously. So don't give them a menu. All right, maybe that's just me being a little negative about it, but I don't think so. Right. But now I want to capture their choice. So I do want to give them a prompt. And here's the prompt. It'll be inside the if statement. I'm going to say, choose your conversion type. So in other words, make your choice from up above. And, really what I want them to type is a number. Okay, so they're going to type 1, 2, 3, or 4. Right now, we want to read that in, but before we read that in, I'm going to do something a little weird. Is way up here at the top. I'm going to create a string variable, called choice. Right, very common thing, and I'm going to set that to a blank string for now. Right. Then down here, after I prompt them, I'm going to capture that. Now, because this is coming in as a string, and I want you to think about this, I don't need to do the thing where I do, convert to int 32. I don't need to do that because I'm not doing math with this. I am grabbing a number, but I'm using it to drive code. I'm not using it to do math. Right. I'm just making a selection. Right. So I'm just going to do a console read line right there. All right. So now we got our menu up. They've made a selection. And so the next thing that we're going to do is based on their selection, we're going to start to process the code. Right. So, and I'm trying to reinforce input, processing, output, that concept that we were talking about earlier. And so let's see what would happen. So let's think about this. A really basic approach to this is I write an if statement that says, if choice is equivalent to 1, do the conversion that relates to teaspoons, right? So number one is teaspoons. If choice is 2, do the conversion that relates to tablespoons, etc. Right? So I would have an else if for 1, 2, 3, and 4. If, else if, else if, else if is the way I'm thinking about it. What's the other possibility? Well, what if they don't make a choice? Right? They don't even type a number and they just press enter. Or what if they type 5? Like, see where I'm going with this? Right. So these are the kind of things you think about as a programmer. You don't think about what they do right. Sometimes you think about what they do wrong. And so here's how I would code this, right? I would first write an if statement, and this is really weird, right? Where I would check to see first if they entered a blank. They didn't type anything in. So if they didn't type any, if they didn't type anything in, what should happen? I guess they don't want the conversion, right? So we're just going to pop them out, right? Okay, so if the choice is, so think about the logic here. If the choice is blank, we want them out of here, right? So that's really going to happen in my else part of this statement. So really what I'm going to do here is I'm going to say the choice is not equal to blank. They actually type something in. Then I'm going to run my other logical code. Okay, so this is where I'm going to put my other if statement. So I'm already nesting an if. So I'm going to say if choice is equivalent to 1. And I want you to notice I'm putting the number 1 in double quotes because we're treating it as text. They're making a selection. Right? I'm going to add curly brackets. And then we do our conversion. All right. So if they make that selection, I'll set up a double variable. And this is for teaspoon. So I'm going to abbreviate it as TSP. It's pretty common in cooking, by the way. And then we'll take the milliliters and we'll divide it by the number that we put up here, right? And I'm not even going to try to remember it. I'm just going to copy paste it, and there it is. So that's the conversion. Now, I think if I remember the instructions correctly, round the amount to 1 decimal place. Okay. All right, let's do that rounding. How can I do the rounding on this? Well, did we learn this? No, I'm going to show it to you right now, right there. I'm going to demonstrate the concept. So I'm going to do this 2 different ways, and I'll show you the way that I think is better, by the way. So one approach would be as I can take that variable and I can use one of the math libraries. So this is something that's built in, but I have to call the math library by using the keyword math with a capital M. And then notice, it's kind of doing the code for me. So it's kind of hard not to accept it, but it's going to round teaspoon. And this will do some rounding here, but I want to control it. And I want to put in 1 decimal spot, like how many digits I want to round to. I don't know if 1 is really enough. Here's how kind of I think about it. Like, what if it's like a quarter teaspoon, 0.25? That would round to 0.3. That doesn't really say a quarter teaspoon to me. So I might round it to 2 places. We'll just follow this. But this is a rounding technique right here. And then once I've done that, I can just do console write line and say, in the format of the output required, 75 milliliters is whatever, so I could do it like that. And, in fact, I got part of that statement already written, right? And I can say is TSP, and then add a descriptor here, teaspoons. Close the double quotes, close the parens, and a semicolon. So that would be one approach. All right. here's kind of my way of thinking about this. Let's try this and see if this even works. I don't want to go like writing all the rest of the code and then a half hour later I run it and nothing works. Right. If I can get one of these to work, and then I have like a formula for building the rest. See the thinking? Right. You don't have to build it all in order to test it. All right. So I'm going to go ahead and run this. Get the console up on the screen here. I'll move it off to the side. You guys can still see the code. And let's just type in the sample amount of 75. Here's my menu. And now I'm going to choose teaspoons. That's the only one that's going to work. I'm going to type 1. And it says 75 milliliters is 15.2 teaspoons. Is that similar to our sample output? Well, we did cups here, so I guess I don't have a sample output for that. But I could test it because I could type 75 milliliters and then switch this to teaspoon and I get 15.2. So I think I'm okay. Right. The other thing that you could test at this point in the program is what happens if somebody types something less than 0 or 0. Okay, so let's run it and test that. So I'll type 0 and nothing happens. Okay. What if the person doesn't make a choice from the menu? So let's say they do type in 75, the menu comes up and they don't make a choice. Okay, that just pops you out too. That's okay. We can put in some error messages here, by the way, to kind of handle that. Like, hey, you should have typed something, too bad, too sad, or whatever. But that's all in the engineering of the code. But so far, so good. I think the logical structure is working. So to continue this then, maybe I should think about like, okay, so if then the choice, and actually I should say else if, right? Because the first scenario doesn't hit, we'll check choice number 2. It's kind of interesting how I threw in the curly bracket there. I think I'm going to go to that approach. Let's do the next formula, which would be this for tablespoons. I do have it pre-configured, right? I'm grabbing the value from up above, right? 14.87 or 787. I could do the conversion the same way again. I could do this convert with math round and then output it just like that. That would work fine. Here's another approach though to consider. And I gotta get my chat window out of the way here. Another way that you can do this is by doing the rounding directly in the console write line. And this is part of the formatting commands that you can use. If you use this equation, and it looks like I rounded to 2 decimal places here, and you can switch that to 1 if you wish, right? So this approach would feed in the variable and then apply a numeric rounding to 1 decimal place. So this approach works too. Notice it saves a step in a sense. It all depends on like what approach you want to use. Neither one is right or wrong. If they both work, they both work. All right, let's keep pressing through the code here. The next statement would then be else if choice equals 3. And let's do both curly brackets and split them. And I want to stick with that Microsoft format for now. It's more comfortable on my eyes. The next conversion, well, this is where I have 2 different numbers. They're just using 240 on this one. So last time I used 236.588, which seems a little bit different to me. But whatever. Potato, right? I'll switch this to 240 just for the sake of it, because this is what Google is telling us to do. And I will make it a 0.0 just to make sure it casts correctly. And then I will do an output. And I'm going to use the kind of the secondary approach here. I do want you to notice a couple things as I'm doing this is the variables I'm creating here for each one of these branches indicates what the thing is. So teaspoons, tablespoon, cups. I'll also do choice number 4. And should I make this just an else? Because if they didn't choose 1, 2, or 3, it should just be an else. You should say no, right? Because they could type a 5 and there's no menu choice for 5. So not a good idea. This one I am going to copy paste the whole thing. And I know you guys are kind of racing to keep up with me here, but remember, you can go back and watch the videos. All right. So here's the conversion for that one. And for whatever reason, last time I was rounding to 2 decimal places, I don't know why. All right. I am going to put in an else here, and my else is going to basically accommodate for anything else they type in, right? And then I'm just going to give them a kind of polite message, right? That was not a correct option. Excuse me, program terminated. And that sounds really geeky, but yeah, okay, so we're done. Thank you. Come again. But they could type anything. It could be a letter, it could be a number, it could be a blank or whatever at this point. This would kind of handle that situation. Now for this bigger if statement here at the top, and I know you guys are still copying that. What if they did type a blank up here? And this would be to the first prompt. Well, I think I want to put an else on that. And so I'm going to come way down here out to the margin now and add an else just in case they were that kind of snarky, I guess. And I want to give them a message in that scenario. So they got the menu and they didn't type anything. And I have a little comment there. It says this will show when the user doesn't type anything when shown the menu. And so this is the message they'll get if they don't type anything at the menu. Nothing was entered, program terminated. One way or the other, we're out. The other thing that I might suggest, and I didn't do this last time, right? I'm going to scroll up on this. If you guys don't mind, I will come back and show all the code. Is if they entered milliliters greater than 0, then we give them the menu. But what happens if they didn't? I might want to give them an else here as well, and this is kind of how programmers start to think. It's like, okay, well, what about this scenario? And what about that scenario? And once again, I'm going to copy this, but I'm going to tweak it. So I'm going to change the verbiage of it. And I'm going to say, if they don't type a valid milliliter amount, we will show them this message. Okay. And okay, I don't know if nothing was entered is correct, because they what they could put in 0 or they could put in a negative number, right? We could say something like, we cannot process that value, program terminated. But either way, the program's going to be done here, even though there's more code to process, right? Because we're not showing them the menu, so therefore they're never going to enter this little branch. All right, let me run this, show you guys how it operates, and then I will review all the code, and then you can try it on your own, and you guys will probably have nuances that you'll have to work out for next week. But let's run this and see what happens. And I'm going to try here to run all the different scenarios that are possible. So one thing that they might do here, once again, is they might type 0 or a negative number or something else. So I'm going to just type 0. All right. Cannot process that value, program terminated. Oh, and then it says nothing was entered, program terminated. Okay, that's kind of like a double error message. So maybe, right? So this is how my brain is thinking. I really don't need this. What do you guys think? Yeah, that's a good idea to get rid of that. So I'm going to get rid of that. I'm going to run it again. And this time I'll just type 0. Okay, nothing was entered, program terminated. Does that make sense? Sure, I guess 0 is kind of nothing. So that works. All right, maybe that's not the best error message. All right, let's run it again. All right, now let's put in a value. We'll just use 75 as an example. All right, now we've already done teaspoons. We know that one works. So let's try tablespoons. We'd have to figure out if that's the correct calculation. So you'll want to verify it. Let's run it again. Same value. This time we'll do cups. If I remember from the example, that is the correct amount. If I run it again and choose quarts. Okay. How many milliliters are there in a quart? Does anybody know this information? Okay, don't rush to give me an answer or anything. That's kind of an interesting thing, right? Okay. How many,
1,000.
okay, yeah, you're getting you're getting there. Somebody kind of knows it. So, like, what value should I type in here to get a whole quart? Bob, you're saying 1,000?
Well,
Isn't
let's
it?
see.
946.4.
Okay, right. So that's what those conversion amounts are about, right? Like 946.4. Let's just type that in 946.4. All right, and we'll see if that's close to a quart. Yeah, that's a quart. There you go. All right, so we can prove that it works. All right, one thing that we didn't test though, and I don't know if you guys caught this, right? So if I run this again, and let's say I put in a value, and then here I type in the wrong thing. What if I type nothing? Okay, that message works. Let's try it again. It doesn't matter what the value is. Let's now type a number that doesn't work, like let's type 5, for example. Okay, that message works too. What if I type a letter? Boom, the program breaks. Okay, so here's something we're going to learn about this as well. Right now, we're not putting in code that protects the program from crashing. We're putting it on the user to enter the right kind of information. Because really, when we do this input statement here, we want to convert that to a double. I can't convert a letter to a double directly. Right. So the program will crash. In future sessions, we'll figure out code that we can write to keep this from happening. Right. So I can't make that stop. Right. So let's also try this, right? Let's put in a number here that's valid. And then we'll make, well, what if we type, okay, well, here we were typing numbers, right? But we know they're being captured as text. Could I type in a letter here? Would this crash it? No, that won't crash it because at this point, at this prompt, we're capturing text, not numbers. All right. Here's what I'm going to do to finish off this recording here is I'm going to scroll through the code real slowly. So at the very end of the video, you'll have a complete capture, right? And some of you are probably screen capturing right now, which is fine. But here's the top part of my code. Scrolling. Next section. Maybe I want to scroll just a little bit more. All right, and then one more scroll. Capture the rest of it, and that's the complete program. Now, what I want you guys to try on your own when when you're offline with this, because you still have to like get it to work and then turn it in, is experiment with a little bit and try a couple of different techniques. If some of you have already worked on this lab, because it does happen that some people work ahead, and there's a different way to do the conversions as well, right? Which is using multiplication. And so that that is not incorrect. It's just an inverse mathematical operation. So there are other ways to do the math, and there's other ways that you can engineer the if statements as well. Somebody comes up with a different approach. I'd love to see it. What I am going to show us next week, by the way, is there's an alternate to doing all these if else ifs called the switch case statement, which is in some ways preferred. And I'll demonstrate the solution to this next week using that format. When we get back together next week, we're going to do a bunch of different little exercises and stuff to kind of reinforce these concepts. But we are over time, and this video will end here, and our session is done.